Hi, I'm Mike Brubaker of Brubaker Farms here in Mount Joy, Pennsylvania. We're in Lancaster County, and we are actually fourth generation is on the farm right now. We're a family operation that over the years we have grown from 18 cows in 1959 up to now we're milking around 1,200 cows, but we have three different family members involved. I'm partner with my brother Tony, and also just this year the next generation, my son joined in ownership as well, and his name's Josh. So the three of us together run Brubaker Farms. So we're a dairy operation that we cover enough acres to feed the 1,200 cows, which titles around 1,700 acres, some owned, some rented. So we work with a lot of good landlords to share their land with us to produce the feed for our cows. So over the years, we've tried to accomplish several goals on our farm. One of which is we want to take care of our people. You know, we do hire non-family members to help us get the job done. So we like to focus on good people. I like to hire people that are smarter than myself. And that's the key to a good manager of any farm or any business, right? So we like to focus on people. We like to focus on taking care of the animals, and that means comfort for our cows, taking care of them, feeding them right, and they're going to return the favor to you by being around for a long time and being good producers of a quality food product, in our case with the dairy, that's milk. But the third leg is we want to take care of our environment by achieving all these things and also taking care of our environment. So we look heavily at sustainability and conservation, water quality, try to keep soil where it belongs, and even air quality. So all those things, but you can't do any of these things if you don't have economics. You have to have some profitability to be able to achieve these other goals that I mentioned. So I did a lot of research on methane digesters. And so that led us to dive in 13, 14 years ago and build an anaerobic methane digester. And I'm going to tell you a little bit more about that. And I heard about something called an anaerobic digester, and I actually signed up for a tour, and I traveled around some neighboring states and toured some anaerobic digesters, and there were only very few of them that were actually working. And what I thought, it was, first of all, awesome to take something like cow manure and to convert it into energy like electric. I thought, wow, that's a value added thing that I could add, always looking for ways to add value to the farm. So I thought that's a great way to add value. But then also in my research, I found out that a digester takes most of the odor out of the manure, about 90% of it. And I thought, wow, where we're farming here, we are smack against the town of Mount Joy. What we do affects our non-farm neighbors. So anyway, we could reduce odor. You know, that's a good thing for public relations. So we like that idea. Then the more research I did, I found out, you know what? Methane digesters are actually really good for the environment. The more methane we could destroy, the better air we have, right? So I'm not a scientist, but from what I'm told, you know, it's a good thing for global warming and all that. And I stay clear of that debate, but what makes sense to me is that I know I'm doing a good thing. So that led me into doing the research, and finally in 2007 we broke ground for our methane digester, and I was able to line up some grant funding to help us to be able to pull that trigger, because it's a big investment to build. So had to put a whole bunch of my money into it, but had some grant assistance, and that is what put me over the edge, gave me at least enough comfort level, and at least reduced my financial risk to the level that helped me to pull the trigger to make the project happen. And so I'm going to tell you a little bit about how the digester works here. So first of all, in the background, back behind me, you can see some barns that have some of our milking cows in, and beyond that we have some heifer barns as well, facilities. Well, all the liquid manure from those facilities is captured and flowed through a series of gravity and some pumps, flows underground and eventually is fed into our digester vessel that is directly behind me. It has the black cover over it. About every 2 hours, we feed this fresh manure into the methane digester. And inside that digester, it maintains about 100-degree temperature. And that is the temperature the little methanogen microbes like to go crazy and munch on any leftover starches, sugars, and convert them quickly to methane. And this is a process, sped up process, that over time methane would be eventually released from cow manure. We speed it up so that we can capture that methane. It's captured under the black cover behind me, and then we send it underground over to my engine generation building. The gas goes through that white silo vessel that is actually a gas scrubber. It cleans the gas up, takes the hydrogen sulfide out of the gas, takes it to a very, very low level, and what that does is it is less corrosive on my engine generator set when the methane goes through. If I clean the gas up, take the H2S out, and then also that same H2S doesn't travel through the engine and out the exhaust. So we capture that hydrogen sulfide, and then we actually inject that sulfur that we capture back into the effluent that eventually goes out to fertilize the fields. The fields need the sulfur, so that's a good thing. We're able to capture it, reuse it. So in our engine building then, we send that methane fuel source. It's powering a large engine that produces 325 kilowatts per hour of electricity on the generation side of that engine. So it's running all the time, 24/7. The only time we shut that engine down is for maintenance and repairs. So we basically have a 97% run time of the engine. 3% of the time is our track record over the last 14 years. It's only been down 3% of the time. So it's been a good thing. It does take attention though, it does take maintenance, so you can't forget about that. You don't just start and forget about it for years. You have to take care of it. So we have that. Along with the engine creates heat. We capture that heat from the engine, we reclaim that thermal energy, and that is what's used to maintain the 100-degree temperature in the digester vessel. So we recycle the heat, the thermal energy, to maintain the temperature of the digester. We still have excess thermal energy, so we have a pipe loop underground throughout the farm that we heat a building, we heat hot water, and we actually pasteurize milk, waste milk. With all this waste thermal energy from that engine, we're able to recycle it, utilize it through the farm, save other costs of whether it's purchased electricity or fossil fuels. We're able to offset that with the waste thermal energy and use it on the farm. So we think that's, we can get pretty excited about that. You know, it's kind of like free energy, right? So after the fresh manure goes in the digester, we target a 21-day retention time to digest that manure. So theoretically, that's how long the manure is in the digester. It's a complete blend, it's a complete mixed digester, so it is a blend all the time. But as we pump fresh manure in, then some digested digestate effluent leaves the digester. So when it leaves the digester, it basically goes over pushes over a dam and goes through a pipe network underground to an effluent tank, and from that tank we have a pump that pumps the digested effluent to our screw press separator. What does that do? The screw press separator separates solids out of the liquid digestate. So the digestate traveling to that point would be about 93% liquid, 7% solids. We send it through the screw press separator and we take about 3% of the solids out of that. So that what remains is about a 97% liquid effluent. And what do we do with these two forms, the solids and the liquids? The solids portion of it we recycle and use for our cow bedding. And all our barns are what we call freestall barns. The cows are free to lay in any stalls and they lay on a mattress, but then it's important on top of that mattress to put a absorbent product that's soft and comfortable for the cows. So this separated solids from the digestate serves that purpose very well. So it's not only comfortable, it's not only recyclable, it helps us to avoid purchase of at least $60,000 to $80,000 a year of sawdust that we don't purchase because we recycle this product. And what makes it such a good product is the digester does a 99% pathogen kill on what goes through it. So this bedding product is a very low pathogen product that is actually more sanitary for cows to lay on than something like sawdust. So the other thing is we can make more separated solids bedding than what we can even need for our dairy. So the nice thing is I work with a neighboring dairy that they purchase some of our excess separated solids to bed their cows. And they started doing that years ago upon the recommendation of their veterinarian. He recommended that they purchase ours because it was actually better for the cows. So that's a neat thing. And the product is also a good fertilizer product. I have a golf course that buys a load or two from me a year to spread this fertilizer on their fairways of their golf course because they like that it's a non-commercial fertilizer source, and they can promote that in that way, spreading it on their fairways. So that's the exciting thing about that product. Now the liquid portion that we separate from the solids that I was just talking about, that is very important for us as a fertilizer source for our crops. We like to spread that liquid right over top of the growing rye, and the rye sucks the nutrients right in and utilizes them, and that helps us to avoid commercial nitrogen purchases for this rye crop that we will mow and chop as forage for the dairy cows for the next year. So it really makes a great hand in hand. So all the liquid manure, not only on top of the rye, goes out before we plant corn, and we also raise wheat. We do raise some soybeans. So basically all the crops that we raise, the target is to produce quality feed for our cows. The only thing that we grow that maybe would leave the farm would be the wheat, the grain part of the wheat. We would sell for cash, but we raise the wheat because we need all the straw from it. So all the straw then is used for not only feeding animals, and a few of the calves and things get some straw for bedding too. So we need the straw. So everything is tied together here in a sustainable way on our farm, that we grow mainly what the dairy needs, and we utilize the byproducts from the dairy, solids for bedding, liquid nutrients for growing crops. So everything is used. That's our goal on this farm, is to reuse everything and have very little waste is our goal. On our dairy, one thing I've learned is that since we're a multi-generational dairy, we know where we have been and where we are today. And so when it comes to like methane emissions, we know what our cows produced back in 1950, and we know what they produce today. Today our dairymen look at rolling herd average. We're running over 30,000 pounds rolling herd average, so we would be considered one of the higher producing herds. And that's, so if a cow now is making 30,000 pounds of milk, a cow is making a good 3 times the amount of milk as one cow did in 1950. And what that does is it reduces carbon emissions per hundredweight of milk, or per gallon of milk that's produced. Now the methane emissions are much less because one cow is producing more with less methane emissions from that cow. So that's a good thing. Dairies that can be very efficient with their cows, keep them healthy, have them producing well, it helps the environment. It actually cuts methane per gallon of milk. So that's a good thing. Looking to the future, we're looking at ways, since we have a lot going on in our farm. I talked about the methane digester. I didn't even mention we have a lot of solar panels on a lot of buildings as well. And then with our no-till and cover cropping, we're beginning a study to see how close we are to being a net zero carbon neutral farm. So it's something that's in our radar. We know the general public is concerned about it. We think we're doing a good job, so we're just starting the process now, working with some people and organizations to hopefully put some facts and data behind what our gut feeling is here on this farm. We think we're pretty close to being carbon neutral from what we do, but we're taking a look at that. And the question is always, why do we have to adapt to what the general public thinks they want? Because a lot of it's not always factual, some of it's subjective, some of it's emotional. So we're hoping the more we can do to at least put the data behind the numbers and to prove what we think we're doing, we think that it will create more public acceptance of what we do, and also maybe even make a better market opportunity for our food products that we produce here on the farm by saying that, look, hey, we not only think we're doing a good job, here are the numbers behind it. So that's kind of one of the next things that we're taking a look at that's in our radar for the future going forward.